Okay, we sort of agreed that I would start saying a few things about the question and issues of origins, which has been the central thing that we've talked about and collaborated on in some sense. As we've understood the universe better and better over several hundred years and learned about origins, and I'll say a little bit about that in a minute, one of the things that's emerged is that the universe is out there, but it doesn't provide much contact for us in terms of questions that matter to all of us, like questions about the meaning of life and the universe and everything. The history of the idea of origins is recent. You may not all fully know that, but for example, when Shakespeare wrote, no one understood anything at all about the natural universe. There was no clue about how anything worked in the universe. The idea that the earth had an origin and a history, or that life had an origin and a history, those are maybe 2 centuries old approximately. The idea that the universe had a history is less than a century old. It never occurred to anyone who was working on it or thinking about it until that recently. And today, of course, you can track many things from the origins of languages to the detailed origins of humans, but that's all relatively new. The more we've learned about it, the more separate it has, in many ways, gotten from us. And one of the things that, or one of the main things that Liz has focused on is to raise those questions and make them more immediate and help people think about them in many ways. The big collider of particles at the European laboratory called CERN, the collider is called the Large Hadron Collider. Its acronym is LHC, which you'll see a lot in newspapers already, and I hope much more soon. That's the largest human effort of any kind to ever do anything, including NASA and fly to the moon and everything else. That collider and its detectors to get information out and probe the universe more deeply involve thousands of people in the construction and interpretation of it. And it's just now starting to get the data and allow the interpretation that we want. Maybe in the next, well, certainly in the next few months, important things should come from that, I think, optimistically, and maybe quite soon, that this huge human effort, so large, is purely undertaken to improve our understanding of the universe and of ideas is a huge source of pride for me and for many of us, because it's about understanding. Another important kind of thing has happened recently that will help immensely from my point of view, and that's that the subject called string theory, which you may have read a lot of things about it that make it sound like it's not real science, but anything you've read like that is actually nonsense and wrong. I would love to explain all that, and maybe a few words later, but it's actually matured into a theory now, and the reason I'm mentioning is that it provides a framework to integrate ideas. If you just get data, it's not clear how much that helps if you learn a fact here or a fact there. But when you have a theoretical framework that relates the successes you have and the new things in one framework, it's very powerful at leading you toward new interpretations and results that I hope will really extend our understanding of origins very deeply. I want to almost end with a quote from Victor Weiskopf, who was a very distinguished physicist mainly in the last century, and somewhat of a mentor of mine. He wrote a lot, and one thing he wrote is a chapter on art and science in one of his books. So let me quote that. Art has the opportunity to remold all that is great and awe-inspiring in our culture, and he's including science there, and to lend it a form that stirs human souls. And that's what I hope that the collaboration in the dance is beginning to do.
Thank you, Gordy. And thank all of you for coming today. It's lovely to be in this building so close to the lake. I grew up in Milwaukee, and it's just such a pleasure to look out over Lake Michigan again, walking here this morning. I wondered about this very first segment with each of us taking a turn, and I was uncertain what to call my own part, and I thought I could call it Everything I Learned from Gordon Kane. Because I have this incredible, distinct, amazing opportunity to partner and learn from Gordy. But like all origins, and this project, The Matter of Origins, in my mind, begins with my meeting Gordy, there was a time before the origin of that. And we can discuss that. But just to take you back a minute, because I do want to bring you to really to how our interaction occurred. But I had been working on a piece about genetics and working with biologists. I won't go into why that piece became important to me or why that question emerged, except to say that if, as an artist, I'm interested in the contemporary questions of my day, many of those stories rest with what is happening in science and its impact on us. And where in our lives do we get to work that out? I often would reflect on, okay, you're living in the world, you think the world is flat, and then and you have a whole sense of yourself in a flat world, and then somebody comes along and says, oh, by the way, it's round. It's actually a sphere. I don't know what that would be like to take that in. How would you, and who would you talk, would that become the subject of the dinner table for the next, 6 months? It's really round out there? Well, I wonder about that, and I feel that in science today, the kinds of things that you guys are doing has an impact on us, and I was thinking that art is one of the places you might kind of work these things out. So that's why I had been spending time with the geneticists, and in that project I had begun, because I was new to science, other than, like many of you, whatever we got in public education growing up. I began to discern some interesting relationships between art and science, which I would describe in a list like this. Tedium. There's a lot of tedium. It's kind of glorious. You go over the data, but it's not tedium if you know it's taking you somewhere or you believe it's taking you somewhere. This is just a remarkable thing for people in our worlds. I think that we shared a certain obsessiveness, like Gordy, as you'll come to see this morning. The kinds of questions you grapple with and stay with for many, many, many years. That's incredible. This obsessiveness, a certain passion and inquiry that you just can stay with something for so long. Artists, scientists together. But there are ways in which we're not alike. And that is some of the things that I've learned from Gordy too. Yes, I learned a lot of physics, or attempted to learn physics, but I learned the way that our own professions, our own disciplines, our own colleagues expect us to behave in the world. So now I'll just get you to, and we'll come back to that because I know Gordy wants to talk about some of that too. Or maybe you'd like to say something now already about that. No? Okay. Okay. I was at the University of Michigan, not with the full piece about genetics, but with a little tiny section of it. And Gordy came to that little lecture, and then we just showed a couple films. And you came up to me afterwards, and this is my version of it. You said something like, well, we want one too. And by which I took to mean the opportunity to explore what dance, and in my case, dance and video and text, may do to bring an expressive force to the physics questions of the day. In my mind, absolutely not. I was not going to do another piece about science. But then I went to a meeting with Gordy and your colleagues, and here's the thing. Everybody was on time. I am, as a dancer and a choreographer, time matters to me. And I'm really a frustrated human for the amount of time I have to waste waiting for people to get on the beat. And they were all there, and I had this little moment of, oh, maybe physicists are like dancers. And it actually, I know it's funny, but it was actually pretty profound. Because, of course, time is one of the things that you think about and we think about. The meeting was really interesting because Gordy began to talk about CERN, which he's going to talk about again in a minute, and about what they were doing there. And he said something like this: we're going to get to the beginning of the universe. And I said, I wasn't very thoughtful in the moment, I just blurted out, but what about the other origin stories? Meaning, what was the dinner conversation going to be like if we find out exactly how the universe is formed? And many of us hold, if not religious beliefs, cultural beliefs, and how every people, every tribe, every people have spent a tremendous amount of their creative life imagining how we got here. So I said that, and you were so respectful. You said back, yes, that's interesting, isn't it? And then he went and rummaged in his files and handed me what would be your PowerPoint, answering that. And it was just such a beautiful exchange. So the outcome was that with Gordy's help, I went to CERN. And I got to meet amazing people. I saw what people were thinking and doing. And they let me come back with a dancer and a videographer. And this is before they pushed the button in the tunnel. We got to go into the tunnel. We got to film in the tunnel. We got to do all this amazing stuff. And a lot of which you can see if you come see the performance. But I'm going to pause now and see what Gordy thinks of my origin story.
Well, it's close enough, I guess. I guess the anecdote about at the end of the afternoon, after some meetings, we were going to meet several people for dinner, and we walked over early to have a glass of wine, and we sort of both blurted out that we had thought the afternoon would be a waste of time, but why not try it? And both of us had exactly that thought in mind, and then stuck with it after it wasn't a waste of time. So that was pretty encouraging about the project, which, I mean, you want to turn more to that maybe.
Yeah. So I was thinking about what happens, well, what is an art project in relationship to science, and what might our mutual goals be? So sometimes I like to think of it as that the whole arc of making a piece of art, from the time you start thinking you're going to do it and all of the rehearsing and all the trial and error, all the way to when you have an audience who actually sees it. There's a lot of process in there that I might describe as creative process on one end, where everything is good and terrific and wonderful, and art making at the other end, where you have to make horrendous decisions. You have to cut 5 minutes. You can't give that dancer a solo. You got the whole thing wrong. The music is terrible, whatever. You're just, and this is all wonderful. This is all grueling. In this process, sometimes in the context of dance, I would add this. When is it embodied knowledge? Like the dancers are actually trying to figure out what he means by something he says. And it's not necessarily interesting choreography. It's just you embody some of the information you're hearing. That's one kind of art practice. And I think for a lot of scientists, the hope is that the art stays there and makes evident to the public what they actually mean. Right? It's like a form of modeling. I'm going to represent for you what is happening at CERN to the best of my ability. I like that. It's interesting. It's not enough. So you see in parts of this piece real attempts at that, and Gordy was just fantastic in the kinds of ways you responded. And not just Gordy, though, it takes a village. And in Gordy's case, you also get his magnificent wife, Lois. And Lois handed me one day a piece of paper, and it was a phone conversation she had recorded of Gordy talking to one of his colleagues. She called it a poem, of which maybe you and I would understand half the words on the page. It was an amazingly written piece of information about science. I took that to the studio, handed it to the dancers. Each dancer got a line. And then the dancers attacked that, yes, with the knowledge of the science behind it, but not entirely. And so begins the act of translation that's no longer, this is actually what it is. It becomes something else. And I think that's an interesting challenge. But Gordy, what did you think would happen when dancers start doing physics?
Oh, I had no idea. My hope was that, one hope is that the results of the science and their interpretation matter to people in a sense, not directly, of course, but in what we learn about the universe and how it works, and how some people felt after they learned from Newton that the sun would come up tomorrow no matter what they said or did or who they gave money to, and you learn things like that. And I hope that the impressions and the insights could be communicated via media like dance to people and give them some impression that they might not have been able to get otherwise, and certainly not from the detailed physics papers or even what they read in the newspapers, which is usually not even right. So I'm hoping that it did that, and I think it might have. I'm not sure. I would like to hear more about that. I think you felt you succeeded in making it possible for that to work, and you and your colleagues, and that was pretty encouraging to me.
So I'm going to ask Gordy one of the questions I asked him very early on, which is, out of all the things that are happening over in CERN, what are the 2 or 3 or 4 things that he wished people knew? As you just heard him say, this is a really interesting thing he just said. Even the newspapers don't have it quite right. And that's where most of us get any information about contemporary science. So I'd love to hear about that. And then I'm going to ask him also to talk, I think we should talk a little bit about some of the unusual things we discovered in each other's worlds. But let's start with, what are those things you wish?
So this, I guess, the question is what might happen in the next year or so that is scientifically exciting, and why. And the answer is that we should discover at that Large Hadron Collider, we call it discovering some particles that weren't known to exist before. And so what? Those particles, though, have huge implications for the ideas. If certain particles exist, if a Higgs boson exists and you read about it in the next few months or even sooner, that tells us that, for example, the universe isn't ever got nothing in it. The Higgs boson is a pervasive field of matter that is present in the universe everywhere, and that steers our views and interpretation of what ideas could help us understand the universe in profound ways. So what CERN will report is that if they detect 2 photons in their detector and they combine them and look at whether those 2 photons are correlated in such a way that they come from Higgs boson decaying into 2 photons, an unstable particle, then that fact, which requires $1 billion worth of detectors and huge amounts of software to untangle, that will tell us about how the universe works in a deep way. And then I want some other particles to be found called superpartners because there's an idea about the underlying symmetries and invariances that the theories that could work should have, and if they work, they imply these particles should be seen. And for the first time, we're in a situation where we have the equipment to see them. That's why the CERN collider is so important. So hopefully within the next year that will occur. And if you read about Higgs bosons or superpartners in the newspapers, then you can probably trust that something happened there. But that's probably all you can trust.
So if you were me, and you had a rehearsal the next day, and you had just heard that. So that's the thing that's just so interesting about this relationship, is partly hearing the commission. I like to say that the commission for making art is everywhere. You know, like Bach must have thought music in the church wasn't good enough. He had to make something else. I mean, the commissions are everywhere. And there, I might say there's a commission here. What would I take from that? So as I'm listening partly for the meaning, because of course in the end, we want it to mean something, but I'm also listening for what I might call the potential actionable ideas in there. And I'm wondering if you heard any. Did you hear some words that he used that if you had to make a dance from, you'd be able to do it? Anybody? Did you hear something? Yeah. All right, this word collision, it's one of the first things we worked with, although it's really hard on the dancers. But yeah, this collision. What else did you hear? Anybody? Yeah. Symmetry. I want you to know, I got hung up in symmetry for about 6 months to my devastating, because I don't like symmetry. And for a lot of excuse the term postmodern. I love what we are. I know that term is horrible, but for a lot of postmodernists, symmetry is not that interesting. And the physicists are talking about symmetry all the time. And even talking about using art as a defense for the idea of symmetry, when in fact a lot of artists don't like it. So we spent a lot of time arguing about that. And I also spent a lot of time in the studio trying to make it work. And it was really healthy for me because it forced me to try things that my peers would laugh at, actually. If I put out too much symmetry, I would be laughed out of my little postmodern, this big community. So, but it surprised me. And actually where I found the solution to at least my dread of symmetry was partly trying to understand what Gordy means by it, because it's not precisely the same as what we mean, but also spending time with my daughter in southern Spain and seeing the incredible, incredible symmetry in the Arab community, the Islamic community of southern Spain, and where I began to see that the symmetry actually is moving. And again, if you see the show, you'll see an attempt at getting at that in a way that I think is interesting. And what else did you hear besides symmetry, collision? And yeah, go ahead. So this comment is about opening the framework, and I just want to say for everybody who just spoke, you can't see them, but I can, they're all moving. This gentleman goes, opening the framework. Up goes his hands, right? I mean, so you know you're onto something when the gesturing begins.
A comment that is perhaps interesting here is the idea that there's no limit and no constraints then. In the physics, there's huge constraints and limits, and almost every idea you try runs into conflict with existing things we already know, and almost everything anyone's ever proposed to go beyond it can be shown quickly to be wrong because it conflicts with something. So we're hugely constrained, and the ideas we're hoping for can evade those constraints. That's partly why we love them. Yeah,
this is one of my favorite things about being a physicist, is this idea of constraints. It would cracked me up. I would be meeting with them, and they would say something like this. Okay, we're going to think about this problem with the constraint that there's no gravity. And then they would think. I don't know if any of you are Harry Potter fans, but my daughter and I again saw all those movies, so I kept likening it to occlumency. This idea that you could actually hold, close your mind to something. And we borrowed this a lot at the Dance Exchange. I don't think you know this, but we would be having meetings and we'd say, okay, we're going to think about this with the constraint that money is not a question. Then we would, but it is kind of an interesting liberation even while you're curtailing your thinking. Yeah. When Gordy just now was talking, the words I wrote down were, he said the word field of matter. I got very interested in fields. What are they? What do they mean to a physicist? Because it's such a beautiful, beautiful image. And in fact, the piece opens with what we call a T field, because there's a link to another story inside the Matter of Origins, the piece you might see, and it involves a tea room. And but I pursued Gordy to explain to me as best you could what a field was, and we used those. That was our physical score. We happened to be using teacups, but the idea of how we eventually moved in space was that, which I really loved. And the other is this whole question of decaying particles. I had trouble understanding this. Gordy has written a beautiful book called The Particle Garden. And if you are interested in understanding any of this particle stuff, it's a great book. Was for me. It's a wonderful book. Would you change it now with all this new, I guess that we'd have to add to it, huh? No? Can you explain that?
The book called The Particle Garden was written for, I guess, for any curious person about the standard model of particle physics, so-called. It's a bad name because you start off with a bunch of different ideas and then one of them emerges as not wrong and you call it the standard model, but it actually turned into the most complete correct theory we have yet. It describes the whole world that we see in a beautiful, correct, well-tested way. So that's just a little book which tries to explain what that stuff is, and that stuff is never going to change, so it doesn't have to be rewritten. Things about what come beyond the standard model to go deeper, those are still being rewritten, but not that one.
When Gordy and I got together yesterday to just reconnect and catch up, of course I always ask him what's happening at CERN. This is really lay language here from me, but there are at least two, actually there's more than two big experimental sites within the way they're functioning there. And you said to me yesterday, they have to cooperate. You want to talk a little bit about that? Because I think this is one of the things that surprised me, again, when these art science things come together, is what are besides the actual making of art and the making of science, what are the other things that are connecting or telling us is changing in the world? I think this is a really interesting version of that.
There are these two large detectors that are the ones that should make the really important discoveries we hope for. They started being designed over 10 years ago. They cost over $1 billion each. They have about 5,000 people working in detail on them to make it work. And inside the detector, if you want to know what came out accurately, you have to know where over 1 million wires are, each one to an accuracy of 1/1,000,000th of a meter. And you have to get information out from those detectors. Light travels a couple feet between two collisions, so you have to get all the information out in nanoseconds if you want to figure it out. Having these people work together over 10 years means they become a kind of, they depend on each other hugely in a way that we're not even used to normally, because if anybody does anything wrong, the whole thing goes wrong. They form a sort of community. There's the ones with one detector are hugely competitive with the people with the other detector, who are a separate group trying to take away the credit for the discoveries, and the detectors are different enough that they're sensitive to one is more sensitive to some things than others, and so how the new things show up matters, and you have to overcome that if you didn't do the right thing. The signals the most important initial signal being looked for is this Higgs boson particle, and it's pretty clear that neither detector can get a definitive answer soon about whether that exists. They might get a hint, but not a definitive answer that's not some statistical accident. So just in the last week or two, the directors of the CERN laboratory have told these people that not only do they have to finish an analysis soon based on data that was taken in the last year but not yet analyzed, maybe being finished, being analyzed now, but the CERN laboratory, which controls many of the resources, insists that they collaborate on getting an answer and combine their data, which is the opposite of the culture they've been in as long as they've been experimental physicists. So it's a huge experiment, not only in the physics, but in how you do physics and in the sociology of these groups and in getting people to do the right thing together. And it's going on right now, and they hope that something's emerging within weeks, but we don't know that yet.
I find that just incredibly interesting because, of course, the work, now I'm spending this semester at Harvard, and it's just one semester, but very interesting. Just watching and hearing how many places from on high are saying there has to be more collaboration within whatever the institution is, and just how difficult that is.
Never before has that.
Yeah, it's incredible. Although there is a kind of collaboration in the physics world that I came into that I was astonished by. And maybe I'll tell this story and then we'll see if you guys have some questions, because we'd love to know what's on your mind. But a couple of times I would be visiting with Gordy and I would ask some questions and he'd go, well, just a minute, let me look this up. And then you'd go to your computer. And there was this amazing sharing of information on the computer among, I don't remember how many theoretical physicists, if it's the whole world of how many few of you there are. But this incredible opening that they all had access to every day from wherever you are. How many people use that system?
Every day, all the people working on theoretical particle physics and cosmology, and also in other fields, post all the papers on an archive on the web, so anybody can access them the next day in the world and know the results. So we've stopped relying on publication to move the field forward. That's what Liz is talking about. We post these papers, someone can see our results, the next day they can post something based on them. If they were working on it, maybe they do it quickly, maybe it takes a week or two. But we now know that if we sleep or eat or take a vacation, someone might beat us out on an idea. So in the world, actively in these fields, from senior students to senior people, there are hundreds of people working on this stuff, and that's the number that you're competing with or being helped by or helping by what you do. So it's a continuous growth of correct results from helping as well, and that's the best way to think of it, but we all do have the competition in mind.
So maybe we could take some time for some questions. It would be great to hear what you're thinking about. And our friend Steve will come around with microphones.
Hello, hello. I'll do my best to get to whoever has their hand up first, too.
As a fellow Washingtonian, it's wonderful to see you here in Chicago, where I moved to, but still my ties there. I used to work at AARP, so I know that you have some ties there as well. You might have said this, I didn't catch it, but what was the origin of this whole thing? What gave you the idea to do this? Did you meet Gordy arbitrarily, I mean, it's a totally unrelated reason, and then realize there was this common thing, or did you decide to put on a dance show about this and find someone who knew something about it, or what?
No, I met Gordy, and it caused me to think this would be an interesting question. That is, but I don't think the spark was just meeting Gordy. I mean, the question had been there for a while, and this is one of the things that I find interesting. Sometimes when, like interviewers or something, I'll say, "Oh, Liz, you're asking such a big question. The beginning of the universe, it's so big, and there's just a little bit of a put down inherent in their question." And I have found myself saying, actually, I don't think it's a big question. I think it's an enduring question. I think it has been part of us, each one of us, at some point in our childhood. We began asking, well, wait a minute. Where am I? Who am I? How did this, I know we all did. And then we put those questions away. I'm not sure why. And I wanted to come back to why we had those questions even. And then how are different people trying, a person like Gordy who spends his entire life thinking about it. So I thought there's just something very connective about it. But that's what did it.
Gordon, are we on the brink, from what I read in newspapers, of expanding a word that we've had in our vocabulary for quite a while, universe, into universes, plural, that science is on the brink of discovering that there's more than one universe, and that the multiplication of the word is mind-boggling, so to speak.
Yes. The thinking about understanding how you can have universes and how they work and behave the way that we're learning they do leads actually in 2 or 3 independent ways to the idea that there are going to be multiple universes, and we live in one, and there's probably others. And it seems like the idea is probably not wrong. It has to be filled out yet, but it works. And it is possible to imagine ways to kind of test that directly. Of course, in science, if you don't test something, you're not really doing the science. But there's another way to test things that it will be sufficient here if it works. If you have a theoretical structure and it predicts many things and it's constrained and you have no choices about the predictions you make, and if one of the predictions is that there are many universes, then that's an idea that can come to be part of the whole theoretical structure and accepted, and it's tested in the sense that other predictions test it, even if you can't do it directly. But there actually are people calculating now ways to look for signals in the sky, so to speak, that could test it more directly. And I think there probably will be direct tests as well within a few years.
Yes, I would just add that we began to call these things in shorthand in the dance making speculations. And towards the end of this dance, there's one of my favorite sections, which is the speculation section. And we play with some of these ideas, but in my imagination, they come in at night, the sort of insomniac that I am, just sort of, wait a minute. But there's also a little bit of a pitfall here for artists and scientists right in this conversation, whereas I often take things metaphorically. And I, as an artist, have the freedom to take some of these ideas and turn them into metaphor, possibly to add meaning, possibly to make connections, and possibly because the idea is so fantastic. So I have, subsequent to working with a physicist, when I've been doing other work in the world, trying to stimulate people's imagination and getting to see that their imaginations, your imaginations, are amazing, amazing places that we don't activate very often. I often say, so there is more than one universe. There's this one, and then there's this one. And just,
we are not speaking metaphorically.
Oh, okay, all right. Good.
So I think we've heard a lot about how particle physics has influenced your interpretation of dance, and I have a good understanding of the marriage between the two at this point, but I'm curious how, Gordy, the newfound knowledge that you have of art and dance and metaphors and interpretation, how is that influencing your interpretation of data from particle physics to science in general?
It would be fun to say that it was, but I don't think so. With me, the importance is more to make opportunities for more and more people to find meaning in the kinds of things we're learning, and that matters to me. So I'm hoping it's working, and for me, I'll say something stronger. For me, the idea that we can understand, that humans, people, can understand our universe and our world is a huge source of dignity and delight. And I don't see any reason why only scientists should have that. I hope everybody can have that. And any way that can make it easier and make more sense is important to me.
We might have time to come back to that question a little bit. I'll say that it's not so much on the physics side, but I see outcomes from the work I did with the geneticists, where there's a more direct impact, specifically around modeling and how scientists use modeling to understand what they see, and the role that embodiment is having on the biologists that I've been working with at Wesleyan University. And I see and perceive that their understanding about both embodiment practice and I would say certain creative practices around multiple ideas for the same thing, multiple images for the same thing you're trying to understand. So I can see a tolerance that is growing in relationship to their research. Let's come back to that in a few years and see if I'm right. But I think that the more time we spend together, the more opportunity there is for some. It's more like changing the way people think about a problem and then the way they go about solving it, where you might see some of that.
Gordy, questioned some of the recent results from CERN questioning Einstein's theory of time, fairly primary theory for those of us interested in physics. And if that is proven to be in fact true, how will that possibly impact on some of your artistic thinking, Liz?
That's easy to answer because the result is certainly nonsense and can never be true. The most interesting part of it is that it's been very much picked up in the media and taken much more seriously than it should have been. And that's the part we're thinking about more. There are a number of calculations already that show that if that were true, then many well-established tests of those theories that are much more accurate and much more precise couldn't have been correct, and they are. So it's clearly not right, and don't worry.
I think the part of that story, though, that is potentially interesting is framing it just a little bit bigger to the question both of how science works to notice what's wrong and fix it, the way scientists push against something to develop it, and what part of that is driven almost by something like, well, I proved Einstein wrong, so therefore I must be great. And I think that sort of psychological piece is an interesting piece that might be of interest across, beyond that, because there's a certain gleefulness in the press, to me, about this, and we'll show that Einstein, and I think that's interesting, that part of it, but I leave the science piece of it to Gordy.
There's one aspect of frontier physics that's ignored is that it leads to development of new technology, because whoever thought that we would have something like quantum computers or quantum cryptography?
Was there a question? Wait,
Yeah.
I agree with you, but
Yeah.
maybe I should just say a little bit about the technology and the science. It does happen that some of the science leads into new technology capabilities, but what really happens is that when you're trying to do science at a frontier where the devices you need to measure new things didn't exist, you have to develop them. So the experimenters are brilliantly clever people who invent new things to achieve their goals, and then those things become modern technology. One example is that the World Wide Web, the idea of clicking and moving things, was invented by particle physicists to allow them to move data in the way they needed to analyze it at universities and labs around the world, invented at CERN as a specific request by Tim Berners-Lee to him to do it. And you can look at the impact of the web on the world and think about that implication. Many other things could be named. Superconducting magnets is another thing. It was developed to make these, accelerate the beams that you need to make the colliders. And I won't go on, but I could for a long time.
This is a very interesting discussion, and I was wondering, Roger Penrose and some other physicists have been grappling with the idea of the physics of consciousness, and I'm wondering, A, if CERN has any possibility of reflecting on that, and B, whether this wouldn't be something fruitful for Liz.
CERN has no possibility of doing something relevant to that. Roger Penrose writes fascinating things, and much of it is important, but I think his ideas on this subject are pretty demonstrably incorrect, because there's calculations in the field of quantum decoherence that show that if you were to affect consciousness, you would need quantum states to stay coherent over a length of time that is many orders of magnitude, many powers of 10 longer than we know the actual loss of coherence of quantum states will be in an organism like people that have some temperature. When you have temperature and thermal motion, you lose the coherence that you need because there are collisions with moving molecules all the time. And so his speculations are taken, well, they're pretty much, in my view, demonstrably not correct, and they're only looked at by a very few people, so I don't think that will go anywhere. But he's in general a brilliant person who has lots of good things.
I don't know about that particular line of inquiry, but what might relate to it is the extent to which brain research in general is extremely interested in artists right now, and by understanding maybe the way the pathways work and things like that, I think I love it. I'm glad it's happening. I'm a little bemused by it because I also want to say, well, of course. I mean, I'm glad the brain pictures show this, but by the way, we kind of know this. But, I don't know why this particular story comes to mind, but if anybody heard the Radio Lab on the Rite of Spring, but it's a wonderful, quick little clip about, they're wondering why in 1904, when the Rite of Spring comes out, that there was this big riot over the music. And this is a brain story, and that someone has been working on brain pathways, and they think that no one had heard those sounds, the dissonance of those sounds, and that in that moment they were actually getting new brain pattern, and that their heads hurt. It just hurt. Bang, take out that umbrella. I think that to me is so incredibly amazing, because most of you probably know sometimes your brains do hurt. Something new is happening, you're breaking a pattern, you're trying something, you're on the edge of something, and it hurts. I think it really, so.
I find your model of integrating science and dance fascinating, and I was wondering if you considered introducing it into education, as far as facilitating teaching physics, and really integrating both brains, the right and the left, and I suppose if you have to express a physics idea in dance, you really know it well.
Well, there is something going around the internet you can see once a year called Dance Your PhD. And it's a very popular contest, and they just held it, and you can see the winners. It's pretty fun. And the rules are that the PhD candidates have to be in it, so you cannot hire ringers. You have to do your own dancing. It's pretty great. But I think it's just an example of what's already happening, that embodied knowledge, the way we learn through our bodies is just incredibly powerful. There's quite a bit of work going on. We, through our good friends at Wesleyan, you can go to us, it's called Science Choreography website, and it's a website for K-12 teachers. It's specifically set up right now for biology, but we'd like to raise some money and do physics. And it's a really simple website. We worked with a lot of teachers, and they said, please don't make it too pretty, don't make it complicated. I only have 15 minutes at night after a long day to try to figure out something new. So it's quite direct and easy, but I'm glad you asked the question, because for a lot of our science partners, both in the genetics piece and in this one, and the one I'm heading into on something about medicine, the part of the attraction is the hope that science education will improve.
So much of our understanding of the world that we live in is embodied, and so much of the ways that we understand abstract concepts comes from our embodied knowledge of the world. Just to give you one example, you guys, I'm sure, understand this already, but when we think about the future, we're thinking ahead, and if you think about the past, you're thinking back. That's what I mean when I said so much of the way that we understand the world is embodied. And of course, dancers think about that all the time. And perhaps this is just ignorance, but it seems to me that so much of cutting-edge physics today is about stuff that we can't experience as in any embodied form. I mean, what they're learning about in CERN is way beyond what we could possibly understand physically. We can only understand it intellectually, and as you said, we can't understand it metaphorically either, or can we?
When you're at the stage where you're doing the science, there are many ways to think about it. People are trying out, and nobody's sure what the right answer is or the right way to handle it is. But once it's, let me start again. In science, over 400 years, there's been progress. Lots of things get known to be true, and they're established forever, like heat is the motion of molecules and such things. So once it's known, it's not at all hard not terribly hard to explain it, and there will be ways developed to explain it, and people will understand not the technical details, but the meaning of it and the context of it and the questions that are being answered by something. And I think that you can see that by looking historically at the things that have been solved over centuries. So the stuff right now looks like you won't get it, and it's hard, but that's partly because we don't know the right answers yet or what's going on, and we'll explain it, and lots of us like writing about it, and we'll write books about it soon after it's found out what actually is the way the things work. So we'll give you something eventually.
But hi, Nick. That was really funny. Your voices are a little disembodied because of the light here. I can't quite tell, and I know that voice. But so I was looking, and I saw it. Yes, in truth, it was Nick. I think embodiment shows what you don't know, on the simplest level. So back to the biologist for a minute. But here, Gordy, could you hold my hand for a second? If we say cells split, okay, look, we just did it. Is that amazing? Okay, let's do it again. We know cells split, right? Okay, split. Like how? Like based on what? Is it a signal? 1, 2, 3? Oh, I know what it is. Some other part of the body does something, and then it split. We don't. And suddenly you realize there's all this stuff you don't know, even though you know they split. So I think even this idea of what we know is aided by embodiment. What the dancers and I found with the physics work is that it's not literal, and that's where maybe, in fact, abstraction is most fantastic. That is, there are many ways to begin to sense the knowledge, I guess I would say. And I think when audiences come to see this show, for example, you would walk out of the show and say, okay, I learned this, this, and this about physics. I think you could walk out and say, here are 4 things I now know I didn't know. But I think you'd know a lot more than those 4 things, if you could, at least I like to believe that that's true. And finally, there's a show at Harvard right now where I'm at. It's called In the Pursuit of Knowledge, and it's a wonderful show. It's about 16th century relationship between scientists and artists. It's the same struggle. It's Dürer, it's all prints. But the question then is, well, if we have a woman holding up the world in the picture versus a man holding up the world in a picture, what does that tell us about the world, right? And so the questions of representation with us, forever, I think.
Okay, we have time for one last quick question.
Okay, I have one question. I associate dance with music, and I wonder whether you are using the music of the spheres, which may just be a metaphor, but maybe it can be culled from the universe.
It's a beautiful piece of music. I'm not using it in this piece, but it is, and I have seen there are other scientists who are doing shows using music like that to incorporate into their science projections and things. It's a wonderful little piece. I'm glad we are on, I know we're at the end, but I just wanted you to hear one last thing from Gordy, because we had agreed we would say one thing about what we're working on, and perhaps since you started us off, you could take us out with.
I think I said everything I'm
Yeah.
working on, and I'm looking forward to these discoveries and interpreting them soon and making big optimistic claims about what they tell us. Higgs bosons and superpartners and string theory, putting it together soon.
Beautiful. Everybody, thank you. Thank you so much.